Okay, 8-6. There's a lot going on in this section. We're going to take it one thing at a time. So square roots, which I think you've probably seen before, right? You have your radical sign. That signifies a square root. It's important to note that a radical operates like parentheses. So anything inside a radical gets done before you run the square root. All right? So for instance, if I said 9 plus 4 in here, that does not mean the square root of 9 plus the square root of 4. Okay? Does not. Right? This is going to be 3 plus 2. It's going to be 5. This is going to be the square root of 13, which is not a number that we can express as a finite decimal. Another big thing about square roots is that technically they produce two answers. The square root of 9, for instance, is 3, but it is also negative 3, because negative 3 times negative 3 is 9. This is the square of the square root property that you can see on page 490. Root x times root x equals the root of x squared, which equals x. So for instance, if I look at this, I would say, well, 3 times 3 equals, and this is root 9 times root 9, that equals 3 squared, right? But so does negative 3 times negative 3. So there's two answers. Most of the time, you're only worried about the positive one. Another thing about square roots is that you can express the power as a fraction. The book doesn't do a good job of highlighting this, so I wanted to point it out. So you can think of this, right? Go back to that square of a square root theorem. Root x times root x. Yeah, it's a crap root, isn't it? There we go. Equals x. All right, well, we know that x is x to the first, right? X to the first power. So if we look back here, these are the same thing. So if we're splitting our first power in half, that means that these are x to the half and x to the half. So a square root, you can also think of it as to the half power. Or, sometimes the book will throw this at you, the 0.5 if it's put in decimal form. That's a good way to get out of some things when you're dealing with problems that are a bit more complex. Like if you see root x times y quantity to the fourth, right? Just like you did in the last section, you're going to distribute that to the fourth. So root x to the fourth, that is x to the half to the fourth, which turns out to be x squared.